Tapas to amplify. And so some of these unmentioned things, I mean, any doubtful things we'll take it up later.
Anything, so I'm just going to the slide directly. So because you got delay. Yeah, so I'll discuss, something called high-level description of quantum safe cryptography, or something called quantum safe crypto system. So actually, people might be thinking, what are the post-quantum cryptography? What are the something called quantum cryptography? I will give an illustration on that. Yeah. So here, thing is that adversary is quantum. That is the quantum machine. So adversary can interact something called target machine classically, quantumly. So if the target machine is classical, then adversary will interact classically, otherwise it will interact quantumly. So yeah, so the thing is that, cryptography means study, right? Cryptography, quantum safe cryptography deals with, quantum safe crypto systems, right? So those crypto systems can be classified into two classes. You can see like classical scheme and quantum schemes, right? And this quantum schemes solely designed for quantum machine, right? And for their security rely on something called principle of quantum mechanics, like something called well-known result. You can see QKD, quantum. Hello, audible? Yeah. Okay. Yeah. Thank you. Yeah, so that quantum scheme, that is designed for quantum computers, and well-known result, something called the quantum key distribution. So, for example, BB84, ECAT91. So, actually, those are based on something called the principle of quantum mechanics, like Heisenberg uncertainty principle, quantum entanglement. And this side, you can see something called designed for classical computers, right? So, like what we are currently using. And again, the thing is that security of those crypto system actually based on some hard problem, right? Something like likewise in case of here quantum principle, here actually we need some sort of hard problem. So that should be quantum safe hard problem. That means no quantum computer can break those hard problem, right? And those scheme further can be divided into two classes. So one run on classical computer, other on quantum computer. Okay, let's talk about first quantum computer. So this kind of security is called the quantum security. So what will happen? So for example, think of, for example, say digital signature, right? So digital signature, so that now this scheme actually run on quantum machine. So that means quantum adversary can interact quantumly or something called in superposition. So adversary's goal is to produce a forgery. So adversary will get some sort of resource like sign oracle. So in this situation, quantum adversary will ask query in superposition and get the corresponding answer in superposition. So that is the difference between something called this classical security and quantum security, right? And now come to this quantum security. So this security is called the quantum post-quantum security. Okay, so not there are many schemes. So where underlying hard problem is quantum safe, but their security is given under something called against classical adversary. Now the question is that whether same protocol can be used against quantum adversary, or same security reduction can be given against quantum adversary. So that's the question. Question is that if the reduction does not involve either rewinding or random oracle, then same proof will work. For example, there are many schemes. For example, you can see many schemes in the symmetric key setting, even lattice-based scheme. So that can be used here also. Now the problem is that if there is a rewinding or random oracle, then there is a problem. So for that, actually, we need something called new proofs, right? So for example, so suppose you have to handle random oracle. So random oracle means here adversary will interact corresponding random oracle. That means hash is modeled as a random function. That means adversary will ask question to the random oracle in quantum and get the answer in quantum. So that is called also quantum random oracle model. So there are many schemes actually, Falcon, FINS Plus, Crystal Kaiba, they are actually NIST candidate after third round of evaluation. And come to this other side, something called rewinding. So rewinding is something called rewinding involves classical setting also. So if there is a signature scheme that is based on Fiat Shamir, then their security actually involves something called rewinding. But rewinding in general does not work in the quantum setting. But recent result, so by this Liu, Gentry and some other people, they have shown that rewinding can be useful in quantum setting. So crystal dilithium is one such a thing that is given security in that quantum random oracle model. So yeah, so these are the things, and thing is that you can see that crystal dilithium, Falcon, Sphinx, all are actually signature candidate. So for example, crystal dilithium and Falcon are based on lattices, and Fins Plus that is based on hashes. And crystal Kyber is a key exchange protocol, so that is based on lattice. So these are the things. So yeah, that's it.